Hello and welcome to the STEMCstudio channel. I'm super excited today because this is the first video in the Geometric Algebra in STEMCstudio series. In this video today, we will develop a vector, and more importantly, we'll develop a vector in JavaScript, or actually TypeScript, and we will add to it operator overloading. I strongly encourage you to follow along with this video by going to STEMCstudio, creating your own project, and coding and doing the kinds of things that I'm doing, and make sure that you can actually do the kinds of things I'm doing. The reason for this is we will be building upon this vector that we create, evolving it into what I call a geometric number. Officially, they're called multivectors, but I think geometric number is also a kind of a good way of describing these things. And these are the numbers that we can use in physics to basically make geometric statements and to encode physical laws. If you know vectors already, then you will have a little bit of a head start here. I'm assuming that you do understand a little bit about vectors actually. I think what's going to be new to most people is coding these and doing kind of computational modeling with them. So coding them in JavaScript, or rather TypeScript, is what we're actually using here. And then adding operator overloading, which is actually unique to STEMCstudio. Although the way that we implement operator overloading is very similar to how it gets done in some other languages. So without further ado, let's get started. I am going to be starting pretty much from scratch today. There is a video about how to use JSXGraph in STEMCstudio, which is a good 2D rendering library. But I'm going to be doing that from scratch, so you won't really need to go and look at that video. All right, so let's start by creating a project, which is a minimal application. And this one we're going to call vectors and operator overloading. Okay, vectors and operator overloading. It's a minimal application, so it's not going to really add anything to the application. So here we are in the workspace of STEMCstudio. This is the program that is provided for us. The README that's displaying on the right here is basically a reflection of the README over here. And what I'm going to do is I'm just going to kind of like clean that up and say this is called vectors and operator overloading. Okay, not really necessary, but I'm just kind of like showing you how you can get your way around the README file. So here is the basic program. Let's execute it by launching the program. And you can see it's just printing hello world. We don't really need that. So let's get rid of that. Now, what we will use is we will use this printing statement that is a nice kind of convenience. It basically will print out things that we create to the web page because this is more convenient than printing things out to the console. Now, we don't really need to see the README file anymore, so I'm just going to hide the documentation like this. Okay, great. So let's go and create our vector class. Okay, so we're going to create a class, and we're going to do that by putting it in a file of the same name. Now, it doesn't really matter that it's the same name. We could call it something else. We call it math.ts or something like that. But I'm going to actually make it the same name. So let's create that file. And what I would like to do is I would like to export a class, which I'm going to call vector, from this file. Okay, so if you're not familiar with ES6 imports, then this is how you create a class, which is an object that you can create an instance of it, and then make it available in other files. We're going to see this a little bit. The linting will kick in, and it's basically trying to tell us to tidy up our code. For the most part, you can get rid of the linting errors by formatting the document, also by right-clicking, formatting the document, or sometimes I will press Control-Shift-I, which is a keyboard shortcut. Control-Shift-I is the keyboard shortcut for formatting the document. Okay, So this is the basic idea. We create a class. How do we use that? Well, we come back to our main file and we're going to import something from the file ./vector. Now we don't have to put in the extension. If we were to put in the extension, we would actually put JS because that is actually what the TypeScript file is going to get converted to. But the normal practice that you'll see in most professional development is people don't even do that. Now I put the cursor right in between the curly braces. I'm going to hit Control Spacebar on my computer. And because there's only one thing in that file, it actually brings it in automatically for me. If I just format again, it's gotten rid of it's added a little bit of white space around it, just prettying it up. Okay, what's going on here? It's declared, but it's never read. Okay, so let's kind of create an instance of our vector. So we'll create const a equals new vector. Okay, and at this point in time, our vector doesn't have any arguments, so there's nothing else that we can pass in here. If you hover over here, it's just a message telling us that a is declared, but we're not using it. Well, one way we can use it is by doing, say, print line, and we pass in a. Okay, now a little bit of white space there, never mind. It's gone. Okay, print line a. So we're getting an output which is saying, this thing is an object, but beyond that, there's no other information, and that's basically because our vector doesn't have a toString method. So I'm going to provide a toString method, and I'm just going to return. Well, I'm just going to say I'm a vector. Okay, and for now, there's not much else I can say. Now we're going to take the viewpoint that a vector is actually, initially we're going to take the viewpoint that the vector is actually just a list of numbers, okay, coordinates, okay. This is how people used to think of vectors. They just thought of them as a collection of numbers, and sometimes you'll have seen r to the n or r squared, which kind of means two numbers, two real numbers. Okay, so that's what we're going to do initially, but we shouldn't think of vectors like that, and I'll elaborate on that a little bit. So the way that we provide these numbers to our vector is through something called a constructor. It's a special method on classes, and this method is called immediately after the new construction here. It's called immediately after, and what it does is it initializes the vector and it gives the vector a chance to set its own values. So in keeping with sort of tradition, we're going to pass in x and y, these sort of coordinates in the plane, because that's what we're actually going to create is a number which is which can represent positions in the plane. It can represent translations in the plane, that kind of thing. Okay, so we pass in x and y, and in TypeScript fashion, we can give these the type number. Now, don't worry for right now. It's telling us, these values are declared but not read. Okay. How would we make these available? Well, one way of saying it is that I really want these things to be available on instances of the class, and I can do that by just adding the public keyword like that. Our old friend whitespace is coming up. You just have to live with that for a time being. You can turn it off. I will show you how to do that in other videos, but I actually think it's better to leave it the way it is. Okay, let's come back to our main file. Okay, and now it's asking us to supply some numbers. So we might provide like 1, 2 or something like that. Okay, and just a little formatting there, and there you have it. So imagine then that this vector is either representing the arrow, if you like, going from the origin to the point x equals 1, y equals 2, or it could just represent a displacement of 1 unit in, and I'll say the x direction for now, and then 2 units in the y direction. We're going to get more precise on this as we go along. Let's at least print this thing a little bit better. So quick shortcut, if you want to just go to something that you've created here, you can type go to definition, okay? And there's my vector, so that's kind of nice. Okay, so what we want to do here is perhaps we really just want to see what this vector is. So I'm going to change my single quotes to these little backticks. Those should be on your keyboard. And I'm going to do something like this. So we'll say this.x and $this.y. So if you've never seen this before, this is what's called a string literal, but actually it's called something else when you can actually substitute parameters in the string. I'll have to recall what that is. And what this allows us to do is essentially take variables and have them be sort of concatenated with the other parts of the string. So the syntax is basically use backticks, and then when you want to insert a variable, it's this dollar curly brace syntax, okay? This, of course, refers to the current instance of our vector. So on this screen here, A would be this. So when I say A.x, I'm going to get 1, and A.2, I'm going to get that. So on the right here, you can see it's printing vector 1, 2. Okay, so far so good. All right, but now I want to just make an observation. Vectors are not really just pairs of numbers. They really have a much deeper geometrical significance. And we really should be thinking of our vector as being, how should we say it? It's composed of scaled quantities, which are what we call the basis vectors. So the basis vectors, you might have come across ijk in 3 dimensions as sort of representing unit vectors in independent directions, and normally actually they're considered to be perpendicular to each other. So likewise, the meaning of the vector here is not that it's 2 numbers, but really it's a kind of composite of these basis vectors. So I'm going to try and sort of communicate that by adding a comment here, and I'm just going to say it constructs the vector v, which is equal to x multiplied by e1 plus y multiplied by e2. Now, at this point, we're having to bootstrap ourselves, and we don't, we don't even have e1 and e2 yet. Okay, so we have to kind of like, this often happens in mathematics. You kind of like have to sort of bootstrap yourself in a little bit. Okay, but what I would like to do is I would really like to use this syntax here rather than this string that we've got down here, okay? Because this really is much more aligned with what we really mean by this vector. Okay, so how do I do that? I'm just going to get rid of that, and I'm just going to say it's x times e1. So this is e1 is a vector in the, simplistically speaking, x direction, and y times e2 is the vector in the y direction. And so the combination of these two things, which is through addition, is what we're actually getting. Okay, so notice that even though we sort of created it like this, what we're actually meaning is something that's more like this. Now, we don't have a good visualization of this yet, so it might be a good idea for us to actually start visualizing this vector before we before we get deeper into actually kind of like constructing this vector. Now, I happen to think that a very convenient, very useful library for doing 2D visualization is JSXGraph. It's normally used for geometry, but we're going to use it for rendering rendering our physical quantities. I guess a vector, you know, it is I guess within the realms of geometry. You don't normally think of vectors when you think of Euclidean geometry, but you know, it is within the realm. So how do we do that? Well, we go to the project settings, because the first thing that we have to do is we actually have to include the JSXGraph library. Okay, so it's down here, JSXGraph. I'm going to get the latest version of JSXGraph, and I will allow minor upgrades. That's described in my STEMCstudio minimum video if you want to go and take a look at that. Now, to actually get a graph on the board, what we're going to do is we're going to add a div to our HTML, and I'm going to call that div diagram, for example. And that basically is something that we can build our board onto. So that's good. Format, nothing else changes. Let's go to here. Now, you'll notice this bit of mechanics, DOM ready. This is basically code that means that this function ready doesn't run until the document object model, that is the visual interface here, has loaded, and that makes it safe to access, right? So that's why we do this little incantation of using DOM ready. And if you want to learn more about it, go look up something called the DOM content loaded event. All right, so what we need to do is create a board. So I'm going to go get JXG. So you just have to kind of like know this incantation. It's jxg.jsxgraph.initBoard. And if you hover over initBoard, it takes an element ID, which is a diagram. And you might notice on the right hand side over here, because the way that we've set up catching the function and printing it, we're getting a little bit of feedback on what's wrong. Okay, so hit diagram. Great, we're progressing. We've got the navigation, but it still looks nothing like a true diagram. So why is that? Well, it's because we basically need to define the size of this element using a style, a bit of CSS. So we're going to set the width to be, say, 500 pixels, and the height to be, say, also 500 pixels. It's kind of useful to make it sort of symmetrical in terms of kind of like not distorting what you see. So we're a little bit better. We can see the copyright coming at the top here. We've got the navigation down here. I'll just size this a little bit, but we really can't see anything else going on in here. So let's come back to our board, and we're going to give it some initial properties. Okay, so if we hover over the init board, you can see that it's waiting to get some board attributes. And if I hit Control Spacebar in here, I can say axis true. And so now we've got some axes. That's kind of good. And we really don't need to embellish this more at this point. There's a lot you can do with JSXGraph. You can go to the website and you know, find their API and examples. It's really good. But you can see this is kind of running from about -5 in the x direction and about 5 in the y direction, down to +5 in the x direction and -5 in the y direction. And so this is going to basically, you know, be a pretty good region for us to look at our vector. Okay, so we've created the board, but we actually don't have a variable that we can assign to the board, so, or a variable that we can use. So we're going to assign the board that we've created, and we'll type it correctly, to a variable which we'll call board. So there, if we hover over board, you can see it's a jxg.board. That's the return value of this function. Now what we want to do is we want to create, let's say, for example, create a, let's go for the jugular. Let's go and see if we can create the arrow right off the bat. So I'm going to create an arrow. I just happen to know, by the way, the way this API works is that you add things to the board by using this create method. If I put my cursor right in here, hit Control Spacebar, it actually gives me some possibilities. So and then I just hit enter. So there's arrow. And then the way this API works is you need to then kind of like supply a sort of an array. And that array contains things. It's called the parents array. It contains things that are appropriate to the arrow. So based upon the way that this is typed, you don't really get any clues from the documentation other than parents are possible, but you will see down here there's an error because I've kind of given it bad information at runtime, and it says I'm looking for either a point or you can give me x1 y1 x2 y2. So let's go with this sort of second syntax here. So let's draw an arrow from the origin to the vector a. So a dot x and a dot y. Okay, and hey presto, this is kind of cool. Okay, we've got a nice visualization. This is just always niggling me a bit. File should end in a new line. Reasons for that, it's all about professional software development, but we'll just comply for right now. Okay, so we have a visual representation of our arrow as being 1 in the x direction and 2 in the y direction. And then down here, we're printing out a. And in fact, I think what I'm going to do is I'm going to just put a little bit of a indication of what a actually happens to be. So a evaluates 2, that's a double arrow. Well, the double arrow symbol kind of means that in certain contexts. In JavaScript, it means something different, but I'll do that. I could say a equals, but that could be equally confusing. A colon, that normally means has type, so whatever, I like this. A evaluates 2, 1e1 and 2e2. So really cool. We have a visual representation. We have really kind of like what we mean. Now let's kind of embellish, go a little bit deeper on our E1, E2. So E1 is really the vector that goes from the origin to the point over here. Okay, so what we can do is we can kind of construct that, right? So we can say, look, const E1 is the vector with an x component, which is 1, and a y component, which is 0. Okay, now this is complaining. Okay, I need to have a new keyword there for the first thing, and then it's saying this is declared, it's not used. Okay, let's go and like just print that. So let's print E1 is equal to E1. And let's even put that on the board. So we'll make, here's another arrow, and this is going to be E1.x, E1.y. Okay, so there you can see that we've got E1, and we've got our vector, which is a. Now let me see if I can put a label on this thing. So I'm going to give our arrow properties, and I'm going to say, so if I hit Control Spacebar, there's something called, Control Spacebar, something called with label true. See, oh yeah, that did help. Although the name it gave it, it sort of assigns names starting with A and then goes through the alphabet. That's not the name we actually want here. We want the name to be E1 or something like E1. Okay, so that's kind of nice. Let's do the same thing then for the other arrow that we have here. So this is actually going to be, A. And then just for completion, let's do E2 as well. So we'll put E2 on the board. Oops. So we'll create E2. And so we got E1 is this, E2. E2, of course, is actually 0, 1. And then let's add another arrow on the board to represent that E2. We'll give the name E2. Okay. So looking good so far. We can see that we've got E2, we've got E1, we've got A. Now, incidentally, it doesn't matter where we put E1 and E2 on the board. These vectors are the same wherever you happen to be on the board, right? So I can sort of slide them around. So what I've done here is I've moved E2 out of the way by adding 2 to the x coordinate, the starting coordinate x value, and adding -3, or subtracting 3 if you want to see it that way, to the n coordinate. And if I change the n coordinate, I need to add 2 and subtract -3. And so as you can see, the result is E2 over here. I'm going to move E1 down same amount, so I'm going to put it like 2 -3, and then I'm going to add 2 and subtract 3 from the n coordinates. So all I've done is kind of like moved E1 and E2 out of the way a little bit, away from A. Okay, let's create a new vector. We'll call it B, and let's say B is a vector which will maybe be like 2 along. So B is a vector which is 2 units in the x direction and maybe -1 units in the y direction. So let's print B. And let's also create an arrow on our diagram to represent B. So, and we'll do it from the origin. So B, B, B. So there you have it. In fact, I've accidentally created B so it's perpendicular to A, and I really kind of like don't want to confuse you. So let's maybe make B go a little bit further in that direction. So it's not actually perpendicular, right? That'll be a little bit more general. All right, so what we have here is a visual representation of A and B. Now we want to really start to get into doing things with our vectors at a coordinate-free level. Okay, so what do I mean by that? Well, let's supposing that there's a new vector that I want to define, and it's equal to A plus B. That is, what I'm doing here is I'm adding vector A to vector B, or vector B to vector A. The one way I could do this, obviously, is I could do something like this. C is, and then I would go A dot X plus B dot X and A dot Y plus B dot Y. Okay. And just to see that that kind of works, let's take a look at C. So print C out. And C, as you can see, it's 4E1. That's kind of correct. And it's 2 minus 1, which is 1E2. And we can actually look at that. So let's create an arrow, which is C. This is going from the origin. And we'll change its label to C. And so C is the sum of A and B. Now, you might be kind of like wondering, well, kind of like, how did that happen? And you can't really see it very much. Well, remember that with vectors, the idea is that you add the vectors head to tail. So the way I should really kind of like do this is I should sort of move the B vector, sort of slide the B vector up here. So the tail of the B vector is at the head of A. And then we should see that B ends right at this point. So one way to do that, I need to move the tail of B 1, 2. So let's do that. So if I move the tail of B 1, 2, I must also move this by 1, 2. Okay, then it sort of all lines up. And in fact, the 1, 2 is actually just it should be pretty obvious. This is just a dot x and a dot y, right? And then this is a dot x and a dot y. Okay, so and then we can kind of like give that is in fact C, but it's also A plus B. Okay. Unfortunately, our the diagram is overlaying these. It's putting them at the end. I think there's a way that we can actually kind of like position it elsewhere. I'm not going to worry too much about that right now. Okay, so what we'd really like to do though is we really like to do something that mathematically looks more like that. Okay, well, as a step to that, let's suppose instead that we could do something like this. Oops. Let's suppose instead that we could do something like this, that C equals A dot add B. This would be defining on A method called add, and then passing in B. So B is sort of on the right hand side in this whole setup. A is on the left hand side, and we sort of add it. Okay. So let's see how that would look. Okay, so we can go to our vector and we can create a method called add, and then it's going to have a parameter which is also a vector coming in. It will return a vector, so this ensures that we actually create a vector. And what we need to do now is we need to do two things. We need to use that parameter and we need to return a vector. So we're going to return a new vector, and we need to give it some values. So the x-coordinate is going to be this plus the right-hand side's x-coordinate. And the y-coordinate is going to be this dot y plus the right-hand side's y-coordinate. Okay, so that all the errors and stuff should go away. So let's go and make sure that that actually gives us the same result. So instead of going C is a new vector like that, I can go C equals A dot, and I just press the dot and you can see add comes up, hit enter, and then I can pass B in. Okay, and I need to say that that's a constant. And we're back to where we were. So that's kind of one improvement that we can make. And this would allow us to kind of like chain things, right? We could kind of like go dot add, and we could add other vectors here, vector D or vector E1 or something like that, right? So we could kind of like keep on chaining. This is one thing that we can do. It actually is more useful, especially for us, to be able to do something which is more like this first. And the way that we do that is with something called operator overloading. Let's leave that like that for a minute. So operator overloading is a way to make it so this plus operator, when it appears between two vectors, and A is a vector and B is a vector, as you can see by hovering over here, B is a vector. B has type vector is how you should read that. B colon vector. B has type vector. The way that we can do that is by defining an operator that will make this so. Now the first thing that we have to do is go to our project settings, and we have to check that operator overloading is checked. If you don't do that, if we uncheck it, then when we actually use it, so if we kind of like try and use it now, I'm going to go const C equals A plus B. Then we'll get a warning. Okay, the operator plus cannot be applied to these types. Okay, this is not something you can ordinarily do in JavaScript or TypeScript, but it's something that STEMCstudio allows you to do. Okay, so we're going to say, okay, we want operator overloading, and now we've got C equals A plus B, okay, but at this point we actually haven't implemented over in the plus operator, and so we're getting an error, okay. So let's implement this operator overloading. So there is a special method. It's called add with double underscores, and it's very similar to the way that we created the method above for add. In fact, it's kind of like so similar, in fact, that you can really use the add method that's above. So in fact, I'm going to do that. So I'm going to return this dot add the right-hand side. Okay, and you see immediately I've done that, it works. So now we actually have overloaded the add method to work. Now there's a lot more to it than this actually, and we will actually get into refining the way this works when we do a little bit more geometric numbers, and we start to have the possibility that we can add other things on the right hand side here. Okay, but this will do. This is a pretty good start. Okay, so let's go look back at our code and we'll see what we've got. Okay, so now we're able to use operator overloading to create our new vector C, and we've done it here in a coordinate free way. Okay, this is enormously powerful. When you think about it, physics doesn't really care about the coordinates that we use. We could use this set of coordinates here, this Cartesian set of coordinates, but you could equally work in a situation where, say, these coordinates have been rotated and they're at some weird angle, or that some scaling has happened and they're sort of expanded. It doesn't matter to physics what you choose to use as your coordinates. This is a principle a deep principle of physics, actually, that we should write down the laws in such a way that we don't care what the coordinate system is. And if we can do that, then we have laws of physics that anybody can do that same experiment with a different kind of coordinate system, and they should get all the same results. Okay, so this is kind of like good. What I would like to do is to show you another technique where we can sort of embellish this a little bit. Vector here has we've constructed a basis vector E1, but E1 is really sort of implicitly part of the vector class, right? Because we did say that any vector is actually this kind of like linear combination of the basis vectors. And so E1 and E2 are kind of assumed really to be part of the vector. So I'm going to go to the vector and I'm going to create static constants on the vector which represent E1 and E2. So static E1 equals new vector, and E1, recall, is 1 in the x direction and nothing in the other direction. And I'm going to do similarly for E2. Static E2 equals new vector, but this time it's 0 and 1. Okay, so now what we should be able to do is we should be able to come over here and we should be able to say, okay, we don't need to create a new constant E1. We should be able to just use vector dot E1, and there you can see the static method. Okay, now what I would normally do in my program is something like this. I would really kind of like define some variable which is local to my file here, my module, and I'd call it E1, and I'd go also const E2 equals vector dot E2, and that's a conflict right there, so I don't need that. and I don't need to refer to this, and everything's good. Okay, now let's just embellish this slightly a little bit more. So here's the first problem. Supposing we've kind of calculated C, but somebody comes along and goes C.x equals, I don't know, 23. Okay, this completely messes things up for us. We want our objects to be essentially immutable, not changeable. Okay, and it's possible for someone to change the coordinates after we create something. This is not the way that mathematical quantities behave. It's quite reasonable in some circumstances. In fact, it's very reasonable in some circumstances in computational modeling to make things mutable. But for our purposes here, we actually don't want to allow mutability. Okay. So what I'm going to do is I'm going over to my vector class, and I want to make this variable x read-only. Okay, meaning it can't be changed. And I'm going to do the same with the y, read-only. Okay, and now you can see there's an error, and it doesn't allow me, cannot assign to x because it's a read-only property. Okay, I can read x, print line c.x. I'm allowed to do that. Okay, and you see the value is 4 here, came out. I'm allowed to do that, and when would I want to do that? Well, really the reason is I'm interacting with a library like JSXGraph here, and I need to know what these kind of coordinates are, okay? But generally, if I'm programming a physical problem, I'm going to try to avoid actually descending down to the coordinate level like here. So this is just when I'm visualizing, but when I'm doing physics, I'm going to try and stay working in this kind of coordinate-free kind of way. Now, additionally, there's a little problem here is that somebody could replace vector.e1, right, with new vector, 0, 0, something like that, right? And this is perfectly legal at this point in time, but we don't want that to be the case. So let's just go to E1. So go to that definition, E1. And we want to make this read-only. Now, the order in which you do this is important. I think you have to put the read-only in here. Let's just demonstrate what happens if you try to put the read-only somewhere else. Read-only static. And it doesn't like that. Static modifier must precede the read-only modifier. Okay. No worries. So we'll just kind of type in read-only here. And we'll do the same for E2. Make that read-only. Okay, and now we can come back to our main file. It says cannot assign to E1 because it's read-only. Okay, so we've really done a couple of nice little additions to our vector to make it a little bit more robust and to make it behave like math. All right, so I think that's probably a good place just to stop right now. We've created a basic vector that can be added to another vector. We've demonstrated how operator overloading works. Now, I should actually tell you, if you want to learn more about operator overloading, there's documentation for it. So just go to the home page here, click on the user guide, and then if you look on the right here, you'll see there's this whole description on what operator overloading is, how it works, how you create these methods, these special methods to implement various overloading of various operators, and the operators are defined here. These are binary operators, so this is like A plus B, but there are unary operators which are single argument operators, so a minus in front of something, or an exclamation point, or a tilde. These are unary operators, and they can return something else. Then there's an example using complex numbers down here of how you can use those. Okay, let's come back to our example here and just summarize where we're at. So we have implemented a vector class, very basic vector class. It's barely more than a collection of numbers, and yet we can add using either a method or using operator overloading, we can print toString the what we really mean by this vector. Okay. So this is a start. We've got a long way to go. We're not even complete on defining what really makes something a vector, and we haven't even gotten close to ideas of magnitude and angles and things like that, which is kind of like where the geometry starts to kind of like come in. And then from there, we would like to go into geometric numbers. Okay. Well, I hope you enjoyed the video as much as I enjoyed getting us started on this road to geometric algebra. You can look forward to the next video where we'll take this vector along to really complete it as a vector, I suppose, adding things like scalar multiplication and all of the other things like subtraction and negation and the identity, which is the zero vector. If you like this video, please give it a thumbs up. It'll help other people to find the video. And if you are interested in seeing more of the videos in the series, the next video in the series, then hit the subscribe button below. Okay, thanks very much, and I will see you very soon with the next video. Take care, happy coding. Bye-bye.